Hello everyone, welcome to another YouTube channel. So let's start with second class of physics. Yesterday we have started electric charges and fields, and we studied till Coulomb's law, and we also saw its scalar and vector form. So before moving on to the superposition principle and electric field, let us try to solve some numericals based on Coulomb's law. Okay, so let me first revise what was Coulomb's law and what was the formula we are going to use today. So one formula that I gave was Q is equal to Ne based on quantization of charge, and the Coulomb's law was based on F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Here you have to keep in mind that charges should be kept in their magnitude, whether it is positive or negative. We have to take positive sign only, and 1 by 4 pi epsilon naught value is equal to 9 into 10 to the power 9, and value with unit will be Newton meter square upon Coulomb square. Okay, and beside this we will use many other formula from class 11th mechanics topic, like F is equal to ma, W is equal to mg. So as the formula comes, I will try to explain the required formula there itself. So let us first write the question. The first question says that the electrostatic force of repulsion between two positively charged ions. If you want, you can write along with me so that you won't feel bored after some time. So the electrostatic force of repulsion between two positively charged ions carrying equal charges is 3.7 into 10 to the power minus 9 Newton when they are separated by a distance of when they are separated by a distance of 5 angstrom. How many electrons are missing from each ion? How many electrons are missing from each ion? So first try to understand what is given in the question and what it is asking us to solve. Okay, so I guess in the question it is directly asking the number of electrons. So it is not asking about q, it is asking about n. So to find n, we have to first calculate q, and once we calculated q, we can use this formula q is equal to Ne, and as we know E is equal to 1.6 into 10 to the power minus 19 Coulomb, and as we have already calculated q, we can easily get this n part. Okay, now to calculate q we have to use Coulomb's law. And the question, what are the things given? The question, it is given the value of force and the distance is given, is not in SI unit. So R here is given as 5 angstrom. So as 1 angstrom is equal to 10 to the power minus 10 meter. So we'll first calculate, convert this into 10 to the power minus 10 meter. Okay, and one more thing is given, the charges which we have to take here are equal in magnitude. So Q1 and Q2 can be taken as Q. Okay, and then if we apply Coulomb's law, so F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Now let us put the value of F. F is 3.7 to the power minus 9 Newton. 1 by 4 pi epsilon naught is 9 to the power 9. Q1 Q2 will become Q square divided by R square, means 5 into 10 to the power minus 10 square. Now ultimately we have to calculate the square root only, so let us try to rearrange these things first. So Q square will become equal to is 3.7 into 10 to the power minus 9, and this 5 square becomes 25, 10 to the power minus 10 square becomes minus 20, and 9 10 to the power 9 will come here. Okay, now overall if we see, this becomes 3.7 into 10 to the power 25 divided by 9. Let us bring this 10 power on one side, so minus 9 and minus 20 becomes minus 29, and when this 10 to the power plus 9 goes up, it will become minus 9. Okay, now try to solve this question with some assumption, because ultimately we have to calculate the square root only. So if we see this and this value can easily be taken out of the square root. So let us take their separate square root: 3.7 square root, 25 square root, 9 square root, and this will be 10 to the power minus 38 square root. So ultimately I think all the values are solvable except under root 3.7. Now under root 25 is 5, this is 3, and this will become 10 to the power minus 19. Now as you know, square root of 3.7 lies between square root of 4 and 1. Okay, no, square root of this is 16, and 3.7 lies between, try to solve like this, 3.7 lies between 4 and 1, so their square root will be also lies between them, so that means the value of 3.7 will be somewhere close to um, between 1 and 2. So let me take a rough value of 1.5. Okay, because uh, it's more close to two sides, so approximately value will come as 5 into 1.5 divided by 3 into 10 to the power minus 9. And if you are not sure, you can easily calculate its square root value also. Let me show you how we'll calculate. So till two places we can calculate. 1 1 is 1, this becomes 2 270, here you have to write 2, and then I guess it will go let us say 9 times. 9 9 ja 81, 9 to ja 18, 18 plus 8 26, this becomes 900, and this becomes 990, and then 18, and this becomes 380. So you can go for 380 to 2 times. Okay, so approximately 1.92, so I think I have taken less value, so you can put here 1.92. 1.92 is roughly 2, so this becomes 10 by 3 and into 10 to the power minus 19. So approximately I think you will get value of Q as 3.3 into 10 to the power minus 19 Coulomb, and exact value is approximately 3.2. Okay, so last we have to calculate number of electrons, so Q is equal to me, so N becomes Q by E. So 3.3 into 10 to the power minus 19 Coulomb, E value is 1.6 10 to the power minus 19 Coulomb. So N will get approximately as 2. As we have increased this value, so we can decrease it also for solving. So 3.2, and it will go exactly 2 times. Okay, so N is equal to 2 is the answer. So sometimes to calculate the value faster, we have to do some assumption, so that we can save our time also, and I don't think your exact answer will be very far away from the approximate answer. They are very close. Okay, let us move to the second question. Now the second question says that the sum of two point charges is 7 microcoulomb. They repel each other with a force of 1 Newton when kept 30 centimeter apart in free space. Calculate the value of each charge. So here again I think we have to assume value of q1 q2 as one as q and another is 7 minus q. So, this is q1, this is q2. They are separated by a distance of 30 centimeters. So 30 centimeter in meters it becomes 0.3 meter, and they are repelling each other with a force of F, and F is equal to 1 Newton. Okay, and they are kept in vacuum, so here dielectric constant will be 1. Now q1 plus q2 is equal to 7 microcoulomb. So if q1 is q, so q2 becomes 7 minus q microcoulomb. Okay, now just apply the formula, you will get the answer. So Coulomb's law says that Coulomb's law says that F is equal to 1 by 4 pi epsilon naught q1 q2 by r square. So as F is equal to 1 Newton, 1 by 4 pi epsilon naught is 9 10 to the power 9. Q1 Q2 we will write as Q multiplied by 7 minus Q, but they are in microcoulomb, we have to multiply 10 to the power minus 6 two times, so it becomes a square of this. R here is 0.3, so 0.3 square. So if you solve this, I think you will get 0.3 square as 0.09 divided by 9, 10 to the power 9 into 10 to the power minus 12, and here it will be 7q minus q square. So I guess you will get a quadratic question here. So let me solve this. This becomes 9 10 to the power minus 2. This 9 and minus 12 become minus 3. It will go up, it will become plus 3 upon 10. This 2 will cancel, and this 7q minus q square, and here I think it will become 10. Okay, so let bring everything on the LHS side, become q square minus 7q plus 10 equal to 0. So here coefficient is 1, so 1 multiplied by 10 is, we are solving by splitting the middle term method, so 10 can be written as minus 5 into minus 2, and since minus 5 and minus 2 on addition will become minus 7, so I think this quadratic expression can be broken down as q square minus 2q minus 5q plus 10 is equal to 0. Now take q as common from the first two terms, become q minus 2, and minus 5 common from the last two terms, become q minus 2. Overall you will get q minus 2 as common and q minus 5. So now it will become q is equal to 2 microcoulomb or 5 microcoulomb. So corresponding to 2 microcoulomb you will get q2 as 5 microcoulomb, and corresponding to 5 microcoulomb is 2 microcoulomb q2 value. So in both the cases either 2 microcoulomb or 5 microcoulomb will be the answer. Okay, so it doesn't matter whether you have taken Q1 S2 or Q2 S2 or Q1 S5 or Q2 S5. Okay, so answer here is 2 microcoulomb and 5 microcoulomb. Now let's move on to the next question. Next question here is from I guess it is from J main paper. So let us try to solve some completed this question. J main April 23. Okay. The question is saying you have 3-point charges. I'm not going to write the complete question because it takes much time. So let me just draw the diagram. Question is saying you have 3 charges. Q is here, minus 2Q is here, and 2Q is here, and positive X is like this. Okay. So Q is at origin. So Q is at origin. Minus 2Q coordinate is 3r/4, and plus 2Q coordinate is r. Okay, so in the diagram it is given like this, and it is saying that Q value is 2 into 10 to the power minus 6 coulomb. R value is 2 centimeter. It is asking the magnitude of net force experienced by the charge minus 2Q is. It is asking magnitude of net force experienced by the charge minus 2Q is in Newton. How much it will be, it is asking. Okay, so this was the question asked in G main April. I think it's not that difficult. So what we have to do here, since net force is asking on minus 2Q, so let us focus on this minus 2Q only. See, this is negative and the charges kept up in lefts and right both are positive, so it will try to attract each other. Okay, so let us name this point as A, B, and C. The minus 2Q will get attracted toward 2Q with some force, calling it as FBC, and minus 2Q will get attracted toward A or plus Q with a force, let us say FBA. So let us first find the value of these two forces, and you cannot add them directly because they are vectors, but they are acting exactly opposite to each other. So here it is B, it is minus 2Q, and this one is FBA and FBC. So I said they are vectors, so you know this the force here FBA and FBC are acting at an angle of 180 degree, that is theta is equal to 180 degree, and when theta is equal to 180 degree, that means cos theta becomes minus 1. So as a resultant of this parallelogram of vector addition, a square plus 2a square plus 2 a square plus b square plus 2ab cos theta, you will get r value as, if this becomes minus 1, so this becomes a square plus b square minus 2ab, this becomes a minus b ka whole square, this becomes a minus b outside. Okay, so simply you have to find the larger force and the smaller force and subtract the smaller force from the larger force, you will get the resultant here. Now let us first calculate FBA. Okay, so FBA will be 1/4 epsilon naught Q, and I told you we have to put magnitude only, so minus 2Q becomes positive automatically, and distance is 3r by 4 whole square. So if we solve this, it will become 1 by 4 epsilon naught 2, I guess it will become 2 1632 by 9 multiplied by q square upon r square. Okay, and FBC becomes 1 by 4 pi epsilon naught 2q multiplied by 2q divided by, and the distance between B and C is r minus 3r by 4, that is r by 4, so this becomes r by 4 whole square. It will be 1 by 4 pi epsilon naught 16 by I think it will become 16 and 4 64 by 9, sorry, no, 64 only, 64 q square by r square. Okay, now let us solve this. Therefore f net, so I guess this FBC is larger because S64 is greater than 32 by 9. So FBC minus FBA. So overall we have common value as 1 by 4 pi epsilon naught q square by r square. This becomes 64 minus 32 by 9. Put the value 1 by 4 pi epsilon naught is 9 to the power 9. Q square means, I think Q value is given in the question, and it is 2 into 10 to the power minus 6. So this becomes 2 into 10 to the power minus 6 square. R value is also given in the question, that is 2 centimeters. So if R is 2 centimeter, that means comes 0.02 meter. So let us put here 0.02 meter square, and here you have to take LCM. Now all you have to do is solve this. Okay, so this 9 and 9 get cancelled. 10 to the power 9, 2 square means 4, 10 to the power minus 6 square means 10 to the power minus 12. This becomes 4 into 10 to the power minus 4, I guess. And here it is 9 4 is 36, 9 6 is 54, 54 plus 3 is 57, and minus 32 becomes 6 minus 2 4, 7 minus 3 4, and this 544. Okay, 544 by 1, so 4 4 get cancelled. I think this and this become minus 3, right? And plus 4, this value will go up and become plus 25 4, so this value has become 10. So I guess our answer will be 5440 Newton. I think this is the answer given in the question also. Okay, so this was the JEE-based question, and since it is competitive, we have to think beyond the board exam also, and it is numerically large also, and conceptually also good question. Okay. So let us solve one more question from G. And that will be the last question of this session. So this question is saying two identical charged spheres, are suspended by strings of equal lengths. The strings makes an angle of 37 degree with each other when suspended in a liquid of density when suspended in a liquid of density 0.3 gram per centimeter cube, the angle remains the same. Okay, if the density of the material of the sphere the density of material of the sphere is 1.4 gram per centimeter cube, the dielectric constant of the liquid is the dielectric constant of the liquid is okay. Here one data is given as 1037 degree is equal to 3 by 4. Okay, so this question was asked in JEE Main January 2024. Okay, so in this question I guess there are two charged metallic spheres suspended by strings of equal length. So string make an angle with each other when suspended in equal. Okay, the density is this much. Okay, now the condition is like that you have a support here and two strings like this, and since they are identical charge sphere, so if charge on one is q, the charge on other will also be q. This angle is 37 degree, right? Now this whole thing, when you put it in a container of a liquid, okay, liquid of density 0.3 gram per centimeter cube. Okay, so uh, this angle remains the same, that is 37 degree, and there is one more density given, the sphere density. This is liquid density and this is sphere density, which is 1.4 gram per centimeter cube. Since both are identical spheres, so there will be repulsion, force of repulsion F will be there, and now try to understand how to. There must be a dielectric constant of this liquid also, and we are asked to find the same thing, that is dielectric constant. Now, when you are putting this system in a liquid, so there must be some different things which is happening here. One thing that you have to notice here, the string is there, so if forces are acting and this angle remains the same, that means there must be the same tension, that is T, which was developed here earlier. Okay, and since there is a density of sphere also, so that means there should be a force mg here also, and the buoyancy effect of the liquid will already considered in this k value, that is dielectric constant, so we don't have to bother about this buoyant force. So as in the question it is given that the angle remains the same, that means the whole thing is in equilibrium. So if we take any of the two charges, like, let me draw it again for you. In the question, I think the length of a string is 0.5 meter. Okay. If total angle is 2 theta, this becomes theta and theta, and this is 0.5 meter. This is 0.5 meter. Okay. So this will become zero point 0.1 meter, zero point 0.1 meter, and here charge q is there, here charge q is there. So F is here. Uh, T will be like this, T will be like this, F will be like this, Mg will be like this. So we'll simply apply Lame's theorem here to balance it. So you can simply say T one part will resolve like this, T one part will resolve like this. So see it is theta to T cos theta will get equal to Mg, and T sin theta will get equal to F, right? So T sin theta is equal to F, and T cos theta is equal to mg, and now if you divide these two, this becomes tan theta is equal to F by mg. So F becomes mg multiplied by tan theta, and from this triangle you can easily see tan theta is 0.1 upon perpendicular by base, 0.1 upon under root 0.5 square minus 0.1 square. Okay, so put all the value here. F will become equal to 1 by 4 epsilon naught, and you have to multiply k here also because it is under liquid. Okay, just one more thing, I think this data 0.5 meter and 0.5 meter is not there, it was taken from some other values, only these two values are given, right? So anyhow we don't need those two values because tan theta is already given. uh, put the value here. uh, q q square upon r square is equal to mg, can be calculated as mg here will be of what sphere, so it will be volume multiplied by rho will give us mass, and into tan theta. Okay, okay, let me first calculate this again. I think till here it is correct, but after this I think we have to do some correction. See, in oil, The buoyant force will act on this sphere corresponding to density of liquid. Okay, so for the same volume, if you multiply the density of liquid, it will give the mass uh, of that portion of volume for the liquid, and when you multiply it by g, it will be the mass, it will the volume displaced. Okay, so weight of the liquid displaced minus when you subtract weight of the liquid displaced from the actual weight, you will get the actual mass. Okay, that is mg dash. So again, v rho lg, in place of m we can write v rho solid sphere, that is g dash. So you can get from here as this m can also be written as v rho s g. Okay, so we get cancelled on both the side. G as rho of s minus rho of liquid become rho of s g dash. So from here you will get g dash as mm, g multiplied by 1 minus rho l by rho s. Okay, yes. Now when the two spheres are kept in oil, so the force become f dash mg dash and tan theta. Since angle remains same, so we will equate it to tan theta only. Now when you divide these two equations, uh, these and these two equations, so tan theta value will get cancelled. F upon mg is equal to f dash upon mg dash. So f and mm also get cancelled. F by f dash value is nothing but the dielectric constant, and here you will get g by g dash. So this become dielectric constant, which we have to calculate. G upon g dash we can write as g into 1 minus rho l by rho s. Okay, g and g also get cancelled out, so k becomes rho s upon rho s minus rho l. In question it is given rho s as 1.4 and rho l is zero point 0.7, so you will get the answer as 1.4 divided by 0.7, answer is 2. Okay, so little bit conceptual. Earlier we were confused this question with the some different question, sorry about that, but I think it's a very good question. Okay, so in today's lecture we have solved this. Here if you put it in this water liquid, so this f becomes f dash, and this mg, and because one more force will act on this, that is a thrust or buoyant force. Okay, so we have to consider that also. It's a very good question because it connects fluid mechanics with Coulomb's law of electrostatic force. So that was all about these four questions that we have solved today, and in next class we will start with superposition principle and electric field. Okay, so thank you for watching this video and have a nice day.